Advanced Higher Chemists, let's go over the curly arrow mechanisms for the nucleophilic substitution reactions. So remember, for a nucleophilic substitution, the mechanism really depends on whether it's going via SN1 kinetics or SN2 kinetics. It will usually go through SN1 if you've got a tertiary haloalkane and SN2 if you've got a primary haloalkane. For secondary ones, it can sometimes be one or the other. But if you're given a secondary haloalkane, you'll probably be given additional information as to what the kinetics actually are. However, if you're not, then it should really give you the marks for going via either mechanism. But also, if it's a large secondary alcohol, then it would most likely be SN1. If it's quite a small secondary alcohol, then it would probably be SN2. In an SN1 mechanism, the haloalkane comes off first of all to create a carbocation intermediate. So your arrow would go from the bond between the carbon and the chlorine, because that's where the electrons are coming from, onto the chlorine because that's where they're going. This then forms your carbocation intermediate, which has a positive charge because it's just had electrons taken away from it, and the chloride ion, which has a negative charge because it's just had electrons put onto it. Then in comes your nucleophile, which is quite often a hydroxide in this case, and that then takes its negative charge and pushes it towards that positive carbocation. The fundamental knowledge of opposite charges attract is key when it comes to the mechanisms. You won't get anything negative going towards anything negative, and you won't get anything positive attracting anything positive. That then gives us our final alcohol product. So that's your mechanism for SN1. If we then go on to SN2, so an SN2 mechanism does not have the halogen coming off first because the carbocation wouldn't be stable enough. So what happens in this case is that your nucleophile then comes and attacks the delta plus carbon, which is delta plus because it's bonded to that electronegative halogen. So that negative charge goes towards that delta positive carbon, and then the electrons flow out onto the delta minus chlorine. This then creates your transition state intermediate, where you have the bonds starting to be formed while this bond's starting to be broken, and everything else is just still around the central carbon like it was before. Then that goes to give your final alcohol product, and then your halogen's just a wee ion on its own that'll probably end up being stabilised by a hydrogen or something. So my advice would be for remembering these mechanisms is to remember that SN1 goes through 2 steps, so the carbocation intermediate has to be formed first, and SN2 goes by 1 step, so it goes through the negative transition state. But also you'll probably need to copy out these a fair few times until it becomes like, I don't know, therapy for you to write them. Bye!